This is a short video to accompany the isostasy lab. Isostasy is the principle that explains that materials find their floating level, their isostatic equilibrium, based on their relative densities. Something floats in a liquid at the level it does based on its density compared to the density of the liquid it's floating in. It's really important to understand in earth science because isostasy explains why mountain ranges are higher than the oceans, even though of course they both float in the asthenosphere below. The oceanic crust and the continental crust that make up the lithosphere plates float at different levels in the denser asthenosphere below. And you'll be able to understand this once you understand isostasy. To really understand isostasy, the first part of this lab has you working on Archimedes' principle. This is the principle that the buoyant force keeping an object afloat is equivalent to the weight of the liquid it displaces. The buoyant force keeping an object afloat is its weight. So we can know the weight of an object if we know the weight of the water it displaces. So I've asked you to demonstrate Archimedes' principle for both the pine block and for the oak block. So a lot easier if you have a number of things assembled in the beginning. Get your 250 ml cylinder, and I've got this filled just about to the very tippy top with water, and I'll show you how we're going to start proceeding. I have it in some type of catch container. I experimented with a lot of different things. I found that an aluminum pie pan, just one of these disposable cheap things that at least some of you have around, seemed to work the best. I don't know if you can see. What was nice is I could actually bend a section of the rim here, and that means that I could essentially make a spout or a funnel. If you have a funnel at home, that would be very handy as well, but you don't have one in your kit, so I'm going to do this as if you don't have one. Get your squirt bottle, put some water in that. You'll use that to top off the graduated cylinder. For later section of the lab, you'll need the ruler, so I have that out. Also for a second section of the lab, your 600 ml beaker. We will need the 100 ml glass graduated cylinder right away. Your dropper will be helpful. I have a different one than you have here, but I know you have an eyedropper. As an alternative, if you don't have something like this aluminum pie pan to catch the water, a china, kind of a sturdy paper plate that has a lip will work. I also tried it with just this deli container I had. This worked really well. The key is that whatever catches the water, we're going to have to be able to kind of bend in some way to measure the water to pour it into a graduated cylinder. So something like a regular plate won't work. It has to be something fairly flexible. And then of course you're going to need your pine blocks and your oak block, your spring scale, because the lab is going to ask you to actually weigh the block to confirm that the weight of the water we displace is going to be equivalent to the weight of your block. And also, just from a practical perspective, I would have some paper towel and napkins. I made quite a mess with this at home. Now the procedure is really simple and it works just beautifully. So start with your 250 ml graduated cylinder filled all the way up to the tippy top here. So I don't know if you can tell from the video, I don't have this quite full. I'm going to use the squirt bottle to very, very carefully add little bits of water. You could, if you prefer, use your eyedropper as well. But the key is to not let this overflow, to get it almost to the drop so that it is overflowing. And I'm intentionally going to use the pine block because it's a little awkward, I noticed, in the way that it floats, but this nonetheless just works like a charm. You'll be able to demonstrate this procedure, this principle, Archimedes' principle, really, really nicely. So the key is to take your pine block and very, very gently put it in the water. It's going to displace water, of course, as the pine block floats in this water. It's going to knock water. It's going to displace water from our graduated cylinder. So very gently, let it float. And you saw what it did. It's really kind of awkward. It really doesn't want to float very well. It's such low density, and it wants to rest on the edge of the graduated cylinder. Guess what? That's just fine. The oak block will actually be easier to work with. What you want to do now is very carefully, we're trying to collect all of this water that has ended up in our pan. I'm actually going to knock a few little drops that I see here off the bottom of the graduated cylinder. Here's why we needed this collection pan. We care about the weight of this water. This is Archimedes' principle, that the weight of this water, the pine block displaced, should equal the weight of the pine block. So pour this into your graduated cylinder, and for the oak block it's going to be quite a significant amount of water. Even for the pine block it will surprise you. So you're going to need the 100 ml graduated cylinder. Make sure you've got all the water, and then simply measure the water that this has displaced. And I don't want to give away this lab answer for you. Imagine, for example, that I've got 10 milliliters of water in here. Well, since the density of water is 1 gram per milliliter, that means that I would have 10 grams worth of water. I would predict then that my pine block weighs 10 grams if we're demonstrating Archimedes' principle. So very simple procedure. You'll do this with the pine block. You'll refill your graduated cylinder up to the tippy top. You'll do the same thing with the oak block in a catch container. You will measure the water that you get from the oak block, and you can tell just by holding them, obviously, that the oak block is heavier. The oak block is denser. You're going to expect to get more water from the oak block.